Hello class. In this video, we're going to talk quickly about the concept of generics. And generics can help us reduce the number of overloaded methods that we have to implement. We would prefer that a compiler detect any errors in our code over canceling at runtime, and generics help us to achieve that goal. A generic is really a parameter, a placeholder for a data type. So any place I could specify a data type like int, I can use a generic instead. So I can define a class or a method with a generic data type, and the compiler will replace that generic with an actual type when the program is compiled. Now, a generic placeholder or generic identifier uses the angle brackets, the greater than and less than symbols, with some sort of indicator within. So this right here, the greater than, less than symbols, enclosing the uppercase T, would be a formal generic type, if you saw that in your code. So we place the formal generic type in our code. Oftentimes with C#, we'll see people use the uppercase T for type or whatever, and E for, I don't know, anything. During compilation, that actual concrete type is going to be determined, and I'll show you how, and the generic is going to be replaced by that actual concrete type. Now that happens during compile time, remember. This replacement is called generic instantiation. Now, the generic type can only be replaced by a reference type, and a reference type is a type that's an object. So we're used to using lowercase int, the lowercase double. Those are value types. Whenever we're speaking of a reference type, we're talking about an object integer, an object double. They are instances of objects that are held in a different location in memory. So there is a difference between this value type int and the object type with the uppercase definition. So we have to use the object type. We can't use a generic with a native data type, int double char. And you'll see that we can put that in our code, but internally C# is going to be changing that to the object representation of that data type. So this native data type then is going to be auto-boxed. And auto-boxing is automatic conversion from a native type like int to a class or object type like integer. Now we talked in chapter 8 about some data representations, and one of those was the stack. And a stack, if you remember, is a data structure that has a last in, first out methodology, kind of like a stack of plates. You want that one on the top, that last one that was into the stack, to be the first one out. That's going to be the best way to handle it, right? So LIFO. So say we want to create a class that does the processing for a stack, and we want this stack to be able to handle many different data types. What we could do is when we define the class, we could place the generic type immediately after the class name. When we're working with a method, we could place that T, uppercase T, then any place that we liked, and wherever it was, the data type replacement would occur for us automatically. How? Well, when we instantiate an instance of our stack, we have to specify the actual data type, the concrete data type. So here we're saying I want to use my stack class that I said was going to use a generic data type. The generic data type that I want to use or implement is an int, which again will be converted internally to an integer. Crazy, huh? And then my name of my stack, and then I specify that it's a new stack, and then I have to specify that generic data type again, and then any parameter values that are going to be passed into the constructor of my stack. Then I could use the methods that are part of my stack class. This line of code says using this integer stack, push the number 47 onto it. Let's back up a slide. And here we see that in our push, we said the parameter type was the same as the generic instantiation type. So in our int stack, since we said that generic type is an integer, that parameter is going to be expected to be an integer. This gives the compiler the ability to determine the actual data type. So we can look at this code, at these pieces of code, and in one place we can say this stack is defined to work with anything. And then when we use that stack, we can say, well, in this case, I want to use that stack with this data type, an integer. This gives us kind of a great way to be dynamic. There's another way, dynamic data type. The dynamic data type can store anything. During compile time, the generics are resolved and instantiated as actual types, but the dynamic data type is not resolved until runtime. So here we see we can set an int value equal to something. We can name these variables whatever we liked, and it will determine the data type at runtime. Now notice the difference. If we get this typing in place at compile time, then we know that we're going to avoid any runtime errors, but within our dynamic data type, we get that ability back. Another data type that's super flexible for us is the Var data type. The Var data type can store, again, anything, but the Var data type is resolved, again, during compile time. So this is a safer item. The Var data type is initialized when it's declared so that its type can be determined at compile time. And then during runtime, those dynamic data types are resolved. So which would be safer? Var, right? Because we're going to determine what actual data type is going to be used there. That typing is going to be concrete at compile time. The more we can get locked in at compile time, the less of an opportunity we have for some sort of unexpected runtime error. Now, in the presentation, we talked just for a moment about boxing and unboxing. And boxing and unboxing is the movement from a value type variable to an object type. So here's an example. We have two types of memory, which we'll look at a little bit deeper in a second. We have the stack and the heap. When I'm working with a native data type or a value type like an integer, like this variable I just give it a value, and it's here on the stack and it's easily accessible. If I set up an object and give it the value of my integer I, my object O and my integer I are both on the heap. They become boxed because we now had to take that integer that was just a reference value and make it into an object so that we could use it to set the value for our other object. So two types of memory, the stack and the heap. The stack is direct to memory, quick access. It's last in, first out, so we usually can find things very easily. It's specific to each thread. If we're using parallel processing or some sort of multi-threading capability, our stack variables will be allocated separately for each thread. Things that are on the stack mostly are going to be native data types, value types. Now the heap is memory that's just kind of a pile. It's allocated in blocks and it's slower access. It's just not as well organized. It's allocated when we're running at runtime. It's application specific, so I would not have that thread separation. And this happens when things have to be turned into objects. Now it looks like I have a typo here. This arrow should say unboxing, is we're taking it out of the heap and putting it back into the stack. We're boxing an element when we have to take that native or value type and turn it into an object. It becomes boxed inside that object. And then if we have to unwrap it back out of that box to turn it back into a native value type, That's the unboxing. So the stack and the heap, together with those a little bit, there's behind the scenes things that we don't see. So these things can be important to the processing of our program. In summary, generics are really placeholders that are resolved at compile time. Generics allow us to use one block of code to process many different data types, and they prevent runtime errors by allowing the compiler to validate an object's data type during the compile. And boxing and unboxing causes unnecessary resource consumption, so we need to be aware of that process happening behind the scenes in our development. Generics offer you a huge amount of capabilities. I hope you'll give them a try and do some practicing with them. Thank you.